Now that we have the specifications for which we need to design the jack for, that is the travel of the jack, that is the 102 mm, the height of the jack for insertion as well as the final lifted condition, that is 160 and 262, and also the load which is acting on the jack. Using these inputs, we can basically arrive at a concept sketch. So this concept sketch is basically a 2D layout of the design, and it can be made parametric. Parametric over here meaning modifiable. And we'll be doing that such that we can arrive at the specifications for the link length. We can arrive at the what is the distance we can keep between the pins, and what is the max size or max height of the top and bottom bracket. All of these specifications we can arrive at by using the parametric sketch. So I will take you through on how to do it in Fusion 360, and with that we can basically form the concept of the jack. So let us start making the parametric sketch. So I have opened up Fusion 360 and this is the model workspace. Under the model workspace, so these are the planes on which we can sketch, and I'll be creating a sketch on one of these planes. Go to create sketch, select the plane. So the next thing which I'm going to do is I'm going to place the points where the pins are going to lie. So I'm going to just arbitrarily place these circles. So I've selected the circle option under the sketch drop down, center diameter circle, and I have placed a circle over here. Now to give it a dimension, I'll press the hotkey D, which will bring up the dimensioning option, and I'm going to dimension it as 10 mm. So the units are in mm. So this diameter of this circle is 10 mm. And what I'm going to do is I'm going to make a vertical which is starting from the origin. So why I'm making this is the jack design is a symmetry design. So you can see over here, this center line is the line of symmetry. If you see on left hand side and right hand side of the jack, the link is a mirror image. So I can just design the jack on one side, that is the sketch on one side, and just mirror it. Now I will dimension this pin with respect to the vertical. So let us keep this distance as 16 mm. 16 mm. And one more line which I am going to draw is the line for the ground. So this line will denote the location of the ground. And from that reference point, I will dimension this point to a distance of 27 mm. So this is an arbitrary distance which I have kept as 27 mm. And I'm going to dimension this line, that is the ground line, the line which denotes the level of the ground. So I'm going to dimension this line with respect to the origin, and would be 15 mm. And now you can see that the line has become black. That means it is fully constrained. So this is the ground line. This is the center vertical line. Now I'm going to go ahead and start designing the linkage. So I'll just place another circle over here, somewhere over here, with the same diameter as 10, and one more circle over here, which is the diameter of 10. So basically this circle denotes the pin for the top bracket, this circle denotes the pin for the bottom bracket, this is the pin through which the lead screw will go. So these are the three pins on 1/2 of the jack. Now, like I did for the ground level, there will be also one more level at the top, that which denotes the topmost face of the top bracket. So I'll make another line for that. That line also will be purely horizontal, and that line will be at a distance of say 35 mm from the topmost pin. Let us keep it at 35. So this is the line at which the body of the vehicle will rest. So this is the topmost surface of the top bracket. Now the next thing which I'm going to do is I'm going to connect these circles with lines. So use the line command, select the center of the circle, connect them. Again use the line command, select the center of the circle, connect them. And this distance I will be keeping, the true distance of this line I will keep it at 150. True distance of this line, again I'll keep it at 150. Okay, there is a missing dimension over here which I have not defined, that is this 16 mm. So because of that the circle has moved over here. I'm just going to do undo, and I'm just going to extend this center line, and I'm going to dimension this circle from this point as 16. So now this is constrained, and now I will dimension this as 150. So as you can see over here, it has gone up. So this 150 and 150 is basically the length of the link. And the final dimension which we need to define is this one, the dimension between the topmost level to the ground level. If we define this dimension, you can see that the whole sketch gets constrained. The whole sketch gets constrained because of defining this dimension. Now by just changing this value, you can change the height of the jack and hence the orientation of the links. So if I put it at 160, you can see how the orientation of the links change. Again, if I put it at 262, you can see it is in the raised condition and the orientation has changed. By making this sketch, what we have done basically is we have sized the different components of the jack. So you can see over here we have laid out a dimension as 35 from the topmost pin to the top level, which actually specifies the size of the bracket which will come there. And also this 27 mm from the pin center to the ground also specifies the height of the bottom bracket. And this 150 specifies the length of the linkage. This 10 mm specifies the size of the pin, and this 16 mm specifies the distance between the pin to the center line of the jack. So we have specified multiple dimensions using this parametric sketch, and also we have made it such in a way that it can be used to simulate the various conditions the jack can be operated in. So at the condition in which it is inserted, that is the ground clearance 160 height, this will be the situation of the linkages, this will be the orientation of the linkages, and when it is raised to the maximum height of 262 plus 102, this will be the orientation of the linkages. So all of this information can be obtained from this parametric sketch and is useful for better understanding the design. Another important dimension which we can obtain from this sketch is the length of the lead screw which is required. So if I just use the dimensioning and just get the dimension between this pin and this center line, I will get a dimension. Although I do not want it to drive the other dimension because it is already constrained, it will show me an error over here. So I'll make it a driven dimension, that is just for reference. So you can see over here, this is the length of the lead screw from this point to the center line of the jack. And if I am changing this value of the length of the lead screw will change. So we can see over here the length of the lead screw from this line to this point will be higher at lower height of the jack. This will be useful for sizing the length of the lead screw as well. The final step over here would be to symmetry this sketch on the other side of the center line. So I'm going to select these two points right here along with the circles, control select all of them, and go to under sketch, go to mirror. 5 are selected. As you can see over here, the ones highlighted in blue are selected. Select the mirror line at this line and press OK. So now by just changing this value, you can see both of these will change. And so this gives a complete picture of how the jack will behave with respect to the different conditions.